Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So my dear students, can you quickly let me know in the chat if all of you can hear me, if I'm perfectly audible, visible to everyone? Can you quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you? Quickly let me know in the chats. Everyone, people. All right. So my dear students, in this particular session, I'll be giving you some 30 short questions. Okay. The duration of this particular session is going to be almost 1 hour or maximum 1 hour 15 minutes. Either it's going to be 1 hour or 1 hour 15 minutes. The session is not going to be very long. Do not worry. Yeah. But one thing I'm telling you, this particular session is going to be very beneficial for all of you. Because the questions which I'm going to discuss with you, you are definitely going to learn a lot of things from the questions that I have planned for all of you in this particular session. Okay? 30 questions exact, and you are definitely going to learn a lot of things from these 30. So is everyone ready? Let me know once in the chats. Quick. Everyone. Perfect, guys. Perfect. So without wasting any more time, let's get going. Let's get started. By the way, you know, Telegram is already blocked, right? A lot of students. I mean, there are a lot of students who are facing this issue, right? For some students, Telegram is blocked. For some, it's still working, right? So I would want you guys to join the WhatsApp channel for time being. The name of the WhatsApp channel is same. Wassim Bhat Chemistry Official. WASSIM BHAT Chemistry Official, right? That's the name of the WhatsApp channel as well. Well, I've shared its link in the Telegram group as well. You can click on that link, which is there in the Telegram group. You'll automatically be added to the WhatsApp channel for time being. Okay? So should we start, people? Yes? Chalo then. Sir, Re-NEET postponed. No, there is nothing like that. Re-NEET is not postponed. Who's telling you that? Who is telling you that? It's not postponed. Don't worry. All right, guys. So let's move on then to the 30 short questions, right? Which will be directly, indirectly asked in your Re-NEET examination, right? And my dear students, as I told you already, you are going to learn a lot of things from these questions, which I have planned for all of you in this particular session. Okay? All right. So let's get going. Let's get started with the first question, my dear students, which is on your screen. The first question which is on your screen. Look at the question carefully and try to answer this particular question. The question says 1 gram of carbonate, 1 gram of carbonate on treatment with excess of HCl produces 0.1186 moles of carbon dioxide. Calculate the molar mass of the metal carbonate, right? My dear students, the question is saying that we have got 1 gram of this carbonate. We have got 1 gram of the metal carbonate. And this 1 gram of metal carbonate, upon reaction with HCl, it is giving us 0.1186 moles of carbon dioxide. 0.1186 moles of carbon dioxide. We have to calculate the molar mass of this particular metal carbonate. Now you are going to use the same concept which I have been teaching you from so long, right? What is the concept? Since the reaction is already balanced, the stoichiometric coefficient here is 1, the stoichiometric coefficient here is 1, you just have to make a stoichiometric equation. You will be writing number of moles of M2CO3 divided by stoichiometric coefficient, that is 1, is equal to number of moles of carbon dioxide divided by stoichiometric coefficient of carbon dioxide, that's again 1, correct? So I can say number of moles of your metal carbonate is equal to number of moles of carbon dioxide, and moles of carbon dioxide are given to me in the question, that is 0.1186. Perfect. Now, my dear students, number of moles of metal carbonate can be written as mass of metal carbonate divided by molar mass of metal carbonate. This is equal to 0.1186. Now, people, tell me one thing. What is the mass of metal carbonate that's given to me? That's 1 gram. So 1 divided by molar mass of metal carbonate is equal to 0.1186. So from here you can calculate molar mass of the metal carbonate, which is 1 divided by 0.1186. Right? Let me know once in the chats if this is perfectly clear to every one of you. Quickly, people, quickly. I'll be using the calculator here because I do not want to waste a lot of time into the calculation. So it's 1 divided by 0.1186. The value comes out to be 1 divided by 0.1186. How much is the value coming out to be? Okay, it is 0.01. All right, my bad. It is not 0.11 here. It is 0.01 that's given in the question. Someone just checked it. It is 0.01186, right? So here I'll be writing 0.01186. Here I'll be again writing 0.01186, right? So it's everywhere going to be 0.01186, 0.01186, and here also it's going to be 0.01186, 0.01186, right? So the answer is approximately going to be 84 grams. So this is the molar mass of the metal carbonate, which I was supposed to calculate. Am I clear with this? Am I clear with this, people? Simple concept. Moles of this divided by stoichiometric coefficient of this is equal to moles of this divided by stoichiometric coefficient of this. That's it. Right? So this was our first question, my dear students, of the today's session. Moving on to the second question. In which of the following delta S is negative? In which of the following delta S is negative? Look at this question carefully. Frequently asked question, guys. In which of the following delta S is negative? What do you think about this question? What do you think about this particular question? I would want the answers in the chats quickly. Quickly, people. Yeah? So basically, if you look carefully, in the first option, my dear students, the stoichiometric coefficient here is 1. Here the stoichiometric coefficient is 2. That means during this process, are the moles increasing? Yes, the moles are increasing. And you know, if the gaseous moles increases, during the process, if the gaseous moles are increasing, that means degree of randomness will be increasing too. And if the degree of randomness is increasing during the process, that means entropy is increasing. And when entropy increases, you know, delta S is taken as positive. Delta S is taken as positive, right? Now, my dear students, N2, whose pressure is 1 atm, N2, whose pressure is 8 atm. You know, what is the relation between entropy and pressure? Entropy and pressure are inversely proportional. Entropy and pressure are inversely proportional. So tell me one thing. During this process, is pressure increasing or decreasing? Pressure is increasing. That means during this process, entropy will be decreasing. During this process, entropy will be decreasing because pressure is increasing. If pressure is increasing, entropy will be decreasing. And if entropy decreases, that means delta S is going to be negative. Delta S is going to be negative, right? Now, my dear students, look at the next one. Look at the next one. Look at the next one. First of all, do you see? Stoichiometric coefficient here is 2. Here it's 2. Here it's 1. So on reactant side, how many gaseous moles do we have? We have got 2 gaseous moles. On the product side, how many we have? 2 plus 1, 3. On reactant side, we have 2 gaseous moles. On product side, we have got 3 gaseous moles. During the process, are the gaseous moles increasing? Yes. So entropy will be increasing. And when entropy increases, delta S is going to be positive. Right? Similarly, diamond. Diamond has got ordered structure. Diamond has got ordered structure. Graphite has got comparatively disordered structure. Graphite has got comparatively disordered structure. So during the process, what do you think? Is the disorder increasing or decreasing? I would say during this process, disorder is increasing. And when disorder increases, entropy increases. When entropy increases, delta S value will be taken as positive. What was I supposed to check? In which of the following delta S is negative? So it's going to be the second option, which is going to be the correct answer of this question. Right? Am I clear with this, people? Everyone in the chats? Done and dusted? Yes. Moving on to the third question, people. Moving on to the third question. Look at this particular question. Look at this particular question. You are given with the reaction. You are given with the reaction. The question is saying if E cell is equal to E naught cell. If E cell is equal to E naught cell at 25 degrees centigrade. Concentration of Fe dye positive is this much. Partial pressure of O2 is given. pH is given as X. Calculate the value of X. Correct? Now understand how do I tackle this sort of a question. The question is from the chapter electrochemistry. My dear students, try to understand. First of all, if I want to write the reaction quotient for this particular reaction, reaction quotient, start with the product. Start with the product. You will write, since this product is an aqueous state, so you'll write concentration of Fe dye positive, raised power stoichiometric coefficient, that's 2, right? This is the liquid state. For liquids, H to mass is 1, nothing to do with that, divided by solid, H to mass 1, nothing to do with this. O2, gaseous state, it's going to be partial pressure of O2, raised power stoichiometric coefficient, that's 1. And this is going to be concentration of H positive, raised power stoichiometric coefficient, that's 4. Perfect. Now tell me one thing. What is the concentration of Fe dye positive that's given to me? 10 raised power minus 3. So 10 raised power minus 3 ka square comes out to be 10 raised power minus 6 divided by. Partial pressure of O2 is again given to me 10 raised power minus 2. 10 raised power minus 2. Now, concentration of H positive. Since, my dear students, pH of the solution is X, which means that concentration of H positive will be 10 raised power minus X molar. Right? So concentration of H positive is 10 raised power minus X raised power 4. So it will be 10 raised power minus 4X. Perfect. So this will be 10 power minus 2, 10 power minus 2 cancels out. So this is going to be 10 raised power minus 4 divided by 10 raised power minus 4X. I believe things are clear till here. Now, my dear students, tell me one thing. In the question, they have mentioned E cell is equal to E naught cell. If you use the Nernst equation says that E cell is equal to E naught cell minus 0. Let me write it somewhere here because we don't have space, much space here. Let me write it downwards here. See guys, as per Nernst equation, E cell is equal to E naught cell minus 0.0591 divided by N log of QC. Correct? This is your Nernst equation. Now the question is saying if E cell is equal to E naught cell. If E cell is equal to E naught cell, tell me when can be E cell equal to E naught cell? I would say E cell will be equal to E naught cell only if this particular term becomes 0. If this particular term becomes 0. And when this term becomes 0, this particular term becomes 0 only when QC value is 1. When QC value is 1, because you know log of 1 is 0. So I would say E cell would be equal to E naught cell only if QC is equal to 1. Now, what is the value of QC which we have? That is 10 raised power minus 4 divided by 10 raised power minus 4x. So this value has to be 1. So from this particular equation, I can say 10 raised power minus 4 is equal to 10 raised power minus 4x, which tells me that x value has to be 1. And that x which we're supposed to calculate. We were supposed to get the value of x only, right? Perfect. Perfect, people. Perfect, perfect, perfect. I've already shared the WhatsApp channel link on my Telegram. Open the Telegram once. In my Telegram channel, you'll find a link. Click on that link. That's a WhatsApp link. Okay? Just join that. I'll be sharing the PDF and stuff on that particular WhatsApp link from now onwards. WhatsApp group. People, is this particular question clear? This is one amazing question, right? It was one amazing question. Good question it is. And this sort of a question can be asked. All right? Perfectly done, guys. Moving on to the next question. Look at this question, guys. Look at this question. What do you think about this? What do you think about this? Again, a good question this is. Again, a good question this is. My dear students, you are given with the reaction. A gives NB. A gives NB. The reaction is given to me. Let me write the reaction here. A gives N times B. Right? The stoichiometric coefficient here is 1. The stoichiometric coefficient here is n. The question is saying, at the point of intersection, the concentration of B for the reaction is. Do you see the question? At the point of intersection, the concentration of B is. How would you solve this question? Understand, people. Try to understand. First of all, if you look at this particular graph, I can say the graph is between concentration versus time. And concentration is decreasing with time. Right? And you know, concentration of reactant decrease with time. So this one is valid for the reactant. And you know, concentration is increasing with time. This particular graph is valid for the product. We have to calculate concentration of B, concentration of product at this particular point of intersection. My dear students, if you look carefully, at the point of intersection, I would say concentration of A and concentration of B, they are equal. At the point of intersection, concentration of reactant and concentration of product, they are equal, right? This is something which is mentioned in the question. At the point of intersection, concentration of reactant, concentration of product, they are equal. I could see that, right? Now, my dear students, let's assume that at time t is equal to 0, the concentration of reactant is A naught. Now, this would be 0. Perfect. Let this be time t. So, at time t, the concentration of reactant would be A naught minus X. Okay. Now, 1 mole gives n moles. X will give n times X. So, I would say at time t, the concentration of reactant is A naught minus X. The concentration of product is n times X. Perfect. And it's mentioned in the question that the concentration of, we have to calculate what? We have to calculate the concentration of B at the point of intersection. So basically, we have to calculate the concentration of B at time t. So as you can see, at time t, concentration of A and B are equal. At time t, the concentration of A and B are equal. So what is the concentration of A at time t? Concentration of A at time t is nothing but A naught minus X is equal. Concentration of B at time t is equal to n times X. My dear students, if you take X on that side, it's going to be A naught is equal to nx plus X. Perfect. If you take X common here, it's going to be n plus 1 is equal to A naught. Therefore, I can say X is equal to A naught divided by n plus 1. What was I supposed to calculate? I was supposed to calculate the concentration of B at the point of intersection. I was supposed to calculate concentration of B at time t. And concentration of B at time t is nothing but n times X. So I can say concentration of B at time t is equal to n times X. And X value you have already calculated. That is A naught divided by n plus 1. So this is the concentration of product. This is the concentration of B. This is the concentration of B at the point of intersection. Or I can say this is the concentration of B at this time t, where both the graphs meet. Tell me once in the chat if this particular question is clear. Again, one amazing question this is. Right? And this sort of a question you can expect because it's a simple question, but conceptual one. Yeah? The ones who have not liked the session yet, I would want every one of you to smash the like button right now. So you can check the option, which option is matching. It is n A naught divided by n plus 1. Correctly done? Perfect, guys. Moving on to one more question. This question I keep on solving almost in all my thermodynamic sessions because I like this question. Okay? Right? Now look at this question. A standard question this is. My dear students, the question is saying which of the following is correct? For the following exothermic reaction. So they are mentioning in the question that the reaction is exothermic. And you know, in the exothermic reaction, heat is absorbed or released. I would say in exothermic reactions, heat is released. And you must be knowing whenever system releases heat, Q value is taken as negative. So the first thing which is coming into my mind, since the reaction is exothermic, therefore Q value is negative. But here they have mentioned Q as positive. So this cannot be the answer. Point number one. Right? My dear students, you should know, when we talk about thermochemistry, we say the reactions are carried out at constant temperature. Apart from constant temperature, this reaction is carried out at constant pressure too. So I would say during this reaction, pressure and temperature have been kept constant. Because temperature is constant by default. Over here, we have kept pressure constant as well. Now tell me one thing. As far as your ideal gas equation is concerned, PV is equal to nRT, right? Pressure and temperature are constant. R value is already constant. So I'll say volume and moles are directly proportional. Volume and moles are directly proportional. Tell me one thing. If moles are increasing, volume would be increasing. If moles are decreasing, volume would be decreasing. Now, my dear students, think logically. How many gaseous moles you are seeing on the reactant side? 3 plus 1, 4. I'm seeing 4 gaseous moles on the reactant side. How many gaseous moles you are seeing on the product side? 1 plus 1, 2. 2 gaseous moles on the product side. Tell me, during the reaction, are the gaseous moles increasing or decreasing? From 4 to 2, gaseous moles are decreasing. And if moles are decreasing, that means volume would be decreasing too. If moles are decreasing, volume would be decreasing. Decrease in the volume is what you call as compression. Decrease in the volume is what you call as compression. And whenever there is compression, work is done by the system or on the system. Work is done on the system. And whenever work is done on the system, W value is taken as positive in chemistry. Right? So W has to be greater than 0. But here they have mentioned W is less than 0. So this cannot be the answer. Do you see how many concepts are involved here? Now, my dear students, understand one more thing. We have to get the relation between delta U and delta H. Tell me one thing. If I ask you what is delta Ng for the reaction, delta Ng will be number of moles of gaseous products, which is 1 plus 1, 2, minus number of moles of gaseous reactant, which is 4. So delta Ng is minus 2. If delta Ng is minus 2, you know delta H is equal to delta U plus delta NGRT, right? So I can say delta H is equal delta U, delta Ng is minus 2 RT. Or I can say delta U is equal to delta H plus 2 RT. What is the meaning of this equation? It means that delta U is greater than what? Delta U is greater than delta H. By how much amount? By this much of amount. Right? So basically, you have to add something to delta H. Then it becomes equal to delta U. So which means that delta U is greater than delta H. So delta U is greater than delta H. This is the correct answer. This will be automatically the incorrect one. Okay? I believe it's clear. Perfect, people. Perfect. Everyone in the chats. Understood? Again, one amazing question. Multi-concepts are involved in this question. Multi-concepts are involved in this particular question. Moving on to one more. Look at this question, guys. Look at this one. What do you think? Just give me a second. Okay. My dear students, if you look at this particular question, a graph is given. Between what? A graph is given. First of all, in order to solve these questions, you should have a perfect understanding of the concepts. Otherwise, you won't be able to do it. Okay? The graph is given between log of T half, T 50%, log of T half and log of A naught. A naught is the initial concentration of reactant. T 50% is the half-life of the reaction. So basically a graph is given. Log of T half versus log of A naught. The graph is a straight line. If the graph is a straight line, it means that T half and A naught, they should be directly proportional. Now, in which order reaction T half and A naught are directly proportional? If you remember your zero order reaction. My dear students, in zero order reactions, you should know that your T half, T1 by 2 or T 50%, that's equal to A naught divided by 2K. So here you can see T half is directly proportional to A naught. Now, I can write it like this as well. I can write 1 by 2K separately and A naught separately. Now, people, think logically. If you apply log on both the sides, it's going to be log of T half is equal to log of 1 divided by 2K multiplied by A naught. Now, if I solve this equation a bit, it's going to be log of T half is equal to log of M into N. Log of M into N is nothing but it is a log of M plus log of N. Perfectly done. Now, my dear students, look at this particular equation carefully. You are plotting this particular term along y-axis. Along y-axis, you are plotted. Log of A naught is plotted along x-axis, right? This is going to be your C, and the sign here is plus, and this is equal. Y is equal to mx plus C. Y is equal to mx plus c. And the value of m here is 1. The value of m here is 1. So y is equal to mx plus c. It's going to be a straight line. It's going to be a straight line with positive slope. With positive slope. That's why the graph is like this. Straight line with positive slope. Right? But what is the intercept here? If you look at the graph, the intercept is 0. Because the graph is starting from origin. Intercept is 0. Intercept 0 means c value is 0. If c is 0, what does that mean? That means this particular term is 0. And log of 1 divided by 2k. This particular term is 0. When can be this particular term 0? Log of x is equal to 0 only if x is equal to 1. Log of x is equal to 0 only if x is equal to 1. That means 1 by 2k value has to be 1. So k has to be equal to 1 by 2. Correct? That's something I was supposed to check. I was supposed to check the order of reaction. That is 0 already. Right? And rate constant of the reaction. Rate constant of the reaction came out to be 1 by 2. Let's say moles per liter per second. Am I clear with this question? Understood? Again, a good question this is. You can only solve these questions if you have the better understanding of the concepts, people. Yeah? I am moving on to one more question. Tell me, 2 statements I've given. Tell me whether both are right, both are wrong, one is right, one is wrong. First of all, the question says, lambda EQ, equivalent conductance. Equivalent conductance of all the electrolytes decreases with increasing concentration. My dear students, you must have heard one thing. When you do the dilution, with the dilution, volume of the solution increases. And when volume increases, it means concentration decreases. Because concentration and volume, they are inversely proportional. Right? Right, people? Dilution, with dilution, volume increases, concentration decreases. Decrease in concentration means increase in volume. That means we are doing dilution. And with dilution, let me tell you, lambda M as well as lambda EQ for all the electrolytes, be it weak electrolyte or strong electrolyte, that increases. So, decrease in concentration means increase in volume, right? Decrease in concentration means increase in volume. Perfect? That means you are doing the dilution. With dilution, lambda M, lambda EQ increases. Now, here it's mentioned. Lambda EQ of all the electrolytes decreases with increasing concentration. Increasing concentration means decreasing volume, right? If you increase the concentration, that means you are decreasing the volume. That means these two will decrease automatically. That's what is mentioned here. Lambda EQ of all the electrolytes decrease with increasing concentration. So this statement is right. Okay, this statement is right. Look at the second one. Number of ions remains equal even at increasing concentration. That's not right. That's not right in case of weak electrolytes. My dear students, when you do the dilution in case of weak electrolytes, due to dilution, ionization increases. Number of ions generated increases. So this particular statement cannot be correct. So one is correct, second is wrong. Because this particular thing is not valid for the weak electrolytes. Right? It is true for strong electrolytes. In case of strong electrolytes, when you do dilution, volume of the solution increases. Number of ions remains the same because strong electrolyte already has got completely ionized. But weak electrolyte, when you do its dilution, number of ions keep on increasing in the solution. Okay? Statement 1 is true, statement 2 is false. Be careful with this sort of a question as well. All right. One question from your equilibrium. Again, a good question. You will be able to solve this sort of a question only if you again have the better understanding of the concepts. Let's understand what the question says. My dear students, I'm giving you the reaction. The reaction is something like this. 2 times HI gives H2 gas. With H2 gas, what do we have? We have got I2 gas. Perfect. We have to get the relation between alpha and Kp. Okay. Now, people, how do we get the relation between alpha and Kp? Try to understand. It will be a bit lengthy question, but it will make your concepts very, very, very clear. Okay. First of all, people, if I say time t is equal to 0, at time t is equal to 0, let the moles of reactant is A. This will be 0, this will be 0. Let the degree of dissociation, degree of ionization is alpha. So I would say at equilibrium, this is going to be A minus A alpha. At equilibrium, moles of reactant will be A minus A alpha. Now, 2 moles are giving 1 mole. So 1 will give 1 by 2. A alpha will give A alpha by 2. Similarly, this will be A alpha by 2. So first of all, I got the moles of all the reactants products present in the container at equilibrium. I got the moles of all the reactants and products present in the container at equilibrium, right? If I got the moles, tell me one thing. How many total moles are there in the container at equilibrium? Total moles in the container at equilibrium will be equal to A minus A alpha plus A alpha by 2 plus A alpha by 2. A alpha by 2, A alpha by 2 makes it A alpha. A alpha alpha cancels. So total moles at equilibrium is equal to A. Total moles at equilibrium is equal to A. Now tell me one thing. If I divide A minus A alpha with total moles, if I divide this A alpha by 2 with total moles, if I divide this A alpha by 2 with total moles, what do I get? I got mole fraction. This is the mole fraction of reactant product in the container at equilibrium. If you got the mole fraction, do one thing. A minus A alpha divided by A. This is the mole fraction of reactant at equilibrium. Multiply with total pressure at equilibrium. Mole fraction of reactant at equilibrium. Multiply with total pressure at equilibrium. Mole fraction of product at equilibrium. Multiply with total pressure. What do I get? I'll be calling these as partial pressures. These are the partial pressures of reactants products at equilibrium. When you multiply mole fraction with total pressure, what do we get? Mole fraction with total pressure gives me what? Gives me partial pressure. Now people, you can do a bit of calculation. So A everywhere gets cancelled. So this will be 1 minus alpha multiplied by PT. Similarly, AA gets cancelled. It's alpha PT divided by 2. Similarly, this is alpha PT divided by 2. So I would say these are the partial pressures of reactants products in the container at equilibrium. Now people, we can do one thing. We can write the expression for Kp. Expression for Kp will be equal to partial pressure of H2 at equilibrium. How much is that? Alpha PT by 2. Alpha PT divided by 2. Right? Raised power stoichiometric coefficient 1. Partial pressure of I2 is same. So it becomes square. Divided by partial pressure of Hi at equilibrium. 1 minus alpha into PT. 1 minus alpha multiplied by PT. Raised power stoichiometric coefficient, that is 2. Perfect. So I would say Kp has to be equal. PT square cancelled out. It's going to be alpha square divided by 2 ka square multiplied by 1 minus alpha ka square. Do you understand? Now people, you can take square common here. When you take square common, it becomes alpha divided by 2 minus 2 alpha. Alpha divided by 2 minus 2 alpha ka square. Right? Is equal to Kp. Is equal to Kp. Now a bit of calculation is needed here. Let's do that calculation too. So what I can do is, if I take square root on this side, it's going to be alpha divided by 2 minus 2 alpha. 2 minus 2 alpha is equal to square root of Kp. Square root of Kp. Or I can say alpha is equal to 2 times square root of Kp minus 2 alpha times square root of Kp. Perfect. If I take this term on this side, it's going to be alpha plus 2 times alpha multiplied by square root of Kp, right, is equal to 2 times square root of Kp. Perfect. Right, people? So if I take alpha common here, it's going to be 1 plus 2 square. Is it clear now? There is something wrong with my internet. I don't know what's wrong. Something is wrong. Something is wrong. Is it fine now? Now everything is okay? Just give me some fire emojis in the chats if everything is okay, people. You know, it's raining. It's raining here. Like it's raining here. Perfect. It's raining. So that is the reason internet might be fluctuating. Now is it clear? Give me some fire emojis in the chats. Everyone, so that I'll get to know whether I'm perfectly fine now. Yeah? It's continuously raining here, so that might be the reason of fluctuation in the internet. Perfect. So I believe this particular question is done, right? And my dear students, again, one amazing question. Okay, we have a proper eye on this particular question as well. All right, let's move on to one more. Tell me what is the answer of this question. Tell me what is the answer of this particular question. Quick. The compound that cannot act. The compound that cannot act both oxidizing and reducing agent. The compound that cannot act both oxidizing and reducing agent. How do I check it? My dear students, if you see this particular option, H3PO4, why is that? Why is that? See, phosphorus. When you calculate its oxidation state, it's +5. It's +5. What is the range of oxidation state that phosphorus shows? The range of oxidation state in case of p block elements is always equal to group number -18 to group number -10. Now, tell me, what is the group number of phosphorus? That is 15. So 15 minus 18 is -3. 15 minus 10 is +5. So this is the lowest possible oxidation state of phosphorus. This is the highest possible oxidation state of phosphorus. Right? Over here, the oxidation state of phosphorus is +5. That means, is phosphorus in lowest oxidation state or highest oxidation state? Phosphorus is already in highest oxidation state. And if phosphorus is in highest oxidation state, it cannot further increase its oxidation state. It cannot further increase its oxidation state. No doubt, it cannot increase its oxidation state, but it can decrease its oxidation state. When it decreases the oxidation state, it will undergo reduction. And the one that undergoes reduction is going to be your oxidizing agent. So this is only your oxidizing agent. This cannot behave like the reducing agent. Okay? So it's option number C. That will be the correct answer of this particular question. Look at this one, people. Look at this one. Look at this one. Look at this one. Again, a good question for all of you. Take it out. Equal volumes of 0.015 molar CH3COH and 0.015 molar NaOH are mixed together. What is the molar conductance of the mixture if kappa, conductivity of CH3CONa in the final solution, is this much? See, how do I deal with such kind of the question? My dear students, as far as this particular question is concerned, you have got CH3COH. You are mixing it with NaOH. So it is basically the acid-base reaction. If it is the acid-base reaction, it is going to lead to the formation of salt and water. The salt is going to be CH3COONa, and with CH3CONa, what do you get? You get water as well. This is the reaction. It's a balanced chemical equation. It's a balanced chemical equation. Now tell me, what is the molarity of CH3COH? Molarity of CH3COH is 0.015, right? Molarity of NaOH is how much? That's again 0.015, right? The question says equal volumes of both. Equal volumes of both. Let the volume of CH3COH be V. Let the volume of this particular NaOH also be V. Let their volume is same, that is equal to V. VML. VML. Right? Now, my dear students, tell me one thing. Time T is equal to 0. Molarity into volume in ml. Molarity into volume in ml. What does that give me? That gives me millimoles. Molarity into volume in ml, that gives me millimoles. So molarity into volume in ml, that gives me millimoles. So how many millimoles of CH3COOH we have? 0.015 V. How many millimoles of NaOH we have? Molarity into volume in ml, that is 0.015 V. In the beginning, this will be 0. This will be 0. Now, my dear students, this is the case of complete neutralization. See, 0.015 divided by V, 0.015 V divided by stoichiometric coefficient. 0.015 V divided by stoichiometric coefficient. Both are getting the equal value. If both are getting the equal value, that means this won't be left. This won't be left. It is a case of complete neutralization. Both are getting completely consumed when you use the limiting region concept. Now, 1 mole is giving 1. So 0.015 V will give 0.015 V. Similarly, this will be 0.015 V. What is the 0.015 V? These are the millimoles of salt. These are the millimoles of salt in the final solution. If you got the millimoles of salt in the final solution, if I ask you, what is the concentration of salt in the final solution? Concentration of salt in the final solution will be equal to millimoles of the salt in the final solution divided by total volume. Total volume is V plus V, that makes it 2V. So VV gets cancelled. The value is 0.015 divided by 2 molar. This is the concentration of the salt in the final solution. This is the concentration of salt in the final solution. Now, if this is the concentration of salt in the final solution, what am I supposed to calculate? Lambda m. Do you know the formula for lambda m? Lambda m is equal to kappa multiplied by 1000 divided by concentration divided by C. Kappa value is given to me in the question, which is 6.3 into 10 raised power minus 4. Into what? Into 1000 divided by C. C is the concentration of salt, which I've already calculated. 0.015 divided by 2. Matter of calculation, get the value of lambda m, which you were supposed to calculate. Understood, people? Again, two concepts were involved here in this question. Okay? Mole concept and the electrochemistry. I hope you remembered how do I deal with such kind of the question. All right. What do you think about this one? Look at the question carefully. Again, this question I've solved many a times with you. This particular question. It is the repeated question. But why I came up with this? Because I feel this sort of a question will be asked. I feel this sort of a question will be asked. Now, how do I deal with this? 25 grams of an unknown hydrocarbon. You have got the unknown hydrocarbon as CXHY. You have taken its 25 grams. 25 grams of an unknown hydrocarbon. Upon burning, so you are doing its combustion, it will lead to the formation of carbon dioxide and water. Now, in the question they have mentioned, 25 grams of hydrocarbon upon burning produces 88 grams of carbon dioxide, and with that, you get 9 grams of water. With that, you get 9 grams of water. Now, people, what do I have to calculate? Empirical formula of this hydrocarbon. See, how do I deal with such kind of a question? First of all, if I talk about carbon dioxide, my dear students, the molar mass of carbon dioxide is 44 grams. Can I say 44 grams of carbon dioxide? This is the general information about carbon dioxide. I'll say 44 grams of carbon dioxide contains 12 grams of carbon. Do you agree with this? 44 grams of carbon dioxide contains 12 grams of carbon. Therefore, 1 gram of carbon dioxide will contain 12 divided by 44 grams of carbon. Right? I would say 88 grams of carbon dioxide. 88 grams of carbon dioxide would contain 12 divided by 44 multiplied by 88. The value comes out to be 24 grams of carbon. So basically, I would say in 88 grams of carbon dioxide, there are 24 grams of carbon. In 88 grams of carbon dioxide, there are 24 grams of carbon. So all this carbon, which is there in carbon dioxide, it has come from where? It has come from hydrocarbon. So in hydrocarbon, there should have been 24 grams of carbon, right? In the hydrocarbon, there should have been 24 grams of carbon, and all this carbon is finally reaching carbon dioxide. Now tell me, what is the mass of this entire hydrocarbon? 25 grams. Out of 25 grams, what is the mass of carbon? 24 grams. So what will be the mass of hydrogen? It will be 1 gram. 1 gram of hydrogen. Perfect. So you got to know one thing. In the hydrocarbon, there was carbon and hydrogen present. Well, the mass of carbon in the hydrocarbon, you got to know as 24 grams. Mass of hydrogen is 1 gram. Right? Atomic mass 12, atomic mass 1. Now, if in order to calculate empirical formula, calculate the atomic ratio. How do you get the atomic ratio? 24 divided by 12, the value is 2. 1 divided by 1, the value is 1. Right? This is the least atomic ratio as well, 2:1. So, as per this, the empirical formula should be C2H1. Well, it's a complete hypothetical question because there is no compound as such, which is your C2H1. But this is the answer. This is the answer. Am I clear with this? Everyone in the chats? Everyone in the chats, people? Is this clear to everyone? I believe so. Look at this particular question, guys. Look at this particular question. 1 mole of non-ideal gas. Non-ideal gas means real gas. 1 mole of non-ideal gas. Non-ideal gas means real gas. Undergoes change in state. 2 atm, 3 liter, 95 Kelvin. So the initial pressure of the gas was 2 atm. Its volume was 3 liters. Its temperature was 95 Kelvin. So this is the value of initial pressure, initial volume of the gas, initial temperature. Now the gas is undergoing change in state. The gas is undergoing change in state. Right? The gas is undergoing change in state. Now, when the gas is present at final state, its final pressure is 4 atm. Its final volume is 5 liters. This is 245 Kelvin. Perfect. This is final pressure. This is final volume. This is final temperature. When the gas is undergoing change in state, the change in internal energy delta U is given to me as 30 atm liter. The change in internal energy delta U is given to me as 30 atm liter. What am I supposed to calculate? I'm supposed to calculate the value of delta H. Calculate the value of delta H. Tell me one thing. Pressure is changing. Yes, from 2 atm to 4 atm. Volume is changing from 3 liters to 5 liters. Pressure as well as volume, both are changing. And you should know, when pressure and volume both change, what is the relation between delta H and delta U, which we use at that point of time? We say delta H is equal to delta U plus, it's going to be P2 V2 minus P1 V1. This is the relation which we use when pressure as well as volume of the gas change simultaneously. Okay, so I can say delta H is equal to, what is delta U? Delta U is given to me as 30. Okay, P2 into V2, 5 4s are 20, minus P1 into V1, 3 into 2 is 6. So this is 14, 30 plus 14 is 44 atm liter. So this is the value of delta H, which you were supposed to calculate in the question. Understood? Only remember one thing, if pressure and volume both are changing, then this is the result which you will be using. Delta H is equal to delta U plus P2 V2 minus P1 V1. Got it? Remember this sort of a question, guys. It can be asked. It can be asked. Look at this question. Look at this question. Look at this question. Sir, they asked in joules. Did they ask the answer in joules? Calculate delta H in joules. Okay. This was delta H in ATM liter. You must be knowing 1 ATM liter is equal to 101.3 joules. Right? So multiply with 101.3. You are done. Okay? Now, guys, look at this question. A sample of fluorocarbon was allowed to expand reversibly and adiabatically. A sample of fluorocarbon was allowed to expand reversibly and adiabatically to twice of its volume. So let the initial volume of the gas is V. The final volume of the gas will be 2 times V. Okay? During the expansion, temperature dropped from 400 Kelvin to 100 Kelvin. That means initial temperature of the gas was 400 Kelvin. The final temperature of the gas is how much? The final temperature of the gas is 100 Kelvin. Perfect. The gas is undergoing which process? A reversible adiabatic process. The gas is undergoing a reversible adiabatic process. What do we have to calculate? We have to calculate CV for the gas. We have to calculate CV for the gas. Do you know one thing? CV is equal to R divided by gamma minus 1. This formula, I believe every one of you will be knowing. This you study in physics as well. CV is equal to R by gamma minus 1. So technically, in order to calculate CV, I need gamma. Now, to calculate gamma, which result I'll be using? The gas is undergoing reversible adiabatic process. So I'll be using the equation which is for reversible adiabatic process. That is T1 V1 raised power gamma minus 1 is equal to T2 V2 raised power gamma minus 1. Now T1 value is 400. V1 value is V raised power gamma minus 1 is equal to T2 value is 100. V2 value is 2 times V raised power gamma minus 1. So double zero cancels. V power gamma minus 1, V power gamma minus 1 cancels, right? So I would say 2 raised power gamma minus 1 is equal to 4, or I can write as 2 ka square. It means that your gamma minus 1 is nothing but 2. Your gamma minus 1 is nothing but 2. So you got the gamma minus 1. You got the gamma minus 1 value. It is 2. So I would say CV is nothing but it's R divided by 2. This is something which you were supposed to calculate. Done and dusted. Yes. Again, one good question and you're sorted. Just remember this. CV is equal to R by gamma minus 1. Gamma you calculated by this particular formula, right? Am I clear? Everyone in the chats, quick. Am I clear, people? Everyone in the chats, quick. Again, I'm telling you, these sort of questions you can only solve if your conceptual understanding is clear. Okay, otherwise, no way. Otherwise, no way. All right. One more question and a nice question. Good question. You'll understand a good concept here. See, guys. Calculate the reduction potential at pH is equal to 14 for Cu dipole to give Cu electrode at 25 degrees centigrade. Ksp is given. E0 value is given. What do we have to calculate? A reduction potential for this particular half cell. A reduction potential for this particular electrode. Right? My dear students, first of all, in order to calculate the reduction potential, since we know reduction takes place at cathode, I'll make sure this electrode behaves like the cathode. And when electrode behaves like the cathode, reduction takes place, I would say copper dye positive would gain 2 electrons, get converted into copper. So first of all, what would be my reaction? The reaction is simple. Copper dye positive would be gaining 2 electrons and would be getting converted into copper solid. This is the reaction which is taking place at cathode, because at cathode only the reduction takes place. Now, what is the value of N here? How many moles of electrons are exchanged? I would say N value here is 2. N value here is 2. If I ask you QC expression, start with the product. This is in solid form. Its active mass is 1. Divide by. This is in aqueous form. So we have to use its concentration. Concentration of copper dye positive raised by stoichiometric coefficient 1. Now tell me one thing. Do we know the concentration of copper dye positive? Is that given to us? Concentration of copper dye positive is nowhere given to us. Now the point is, how do I calculate the concentration of copper dye positive? How do I calculate concentration of copper dye positive? For that, Ksp for CuOH whole twice is given. You tell me one thing. CuOH whole twice, how it dissociates? Cu dye positive plus 2 times OH negative. If you write the Ksp expression, how do you write Ksp expression? Concentration of copper dye positive raised power stoichiometric coefficient 1. Concentration of OH negative raised power stoichiometric coefficient 2. Now, since Ksp is given, KSP is given, right? What do we need? We need concentration of copper dye positive. So that I'll put it here. But concentration of copper dye positive you can only get if you know the OH negative concentration. If you know the OH negative concentration. How do I get the OH negative concentration? For that, pH is given. pH is given to me as 14. You know, if pH is 14, one result you know, pH plus POH at 25 degrees centigrade. That's always 14. Since if pH is 14, I can say POH is equal to 0. 14 minus 14 is 0. Right? What is P? P is minus log. Minus log of what? Minus log of OH negative concentration is equal to 0. And the base is 10 here. Right? So I would say OH negative concentration is equal to 1. OH negative concentration is equal to 1 molar. Because log of 1 will be 0. Perfect. If OH negative concentration is 1, it means that concentration of copper dye positive will be equal to KSP. And KSP is how much? 10 raised power minus 19. Right? So you got the concentration of copper dye positive. My dear students, if you got the concentration of copper dye positive, so it's 1 divided by 10 raised power minus 19. It comes out to be 10 raised power 19. So this is your QC. You got N value, you got Q value. Now, use the Nernst equation. Nernst equation says that ERED, reduction potential of the electrode, is equal to E naught RED, which is SRP, minus 0.0591 divided by N. That is going to be log of QC. Perfect. So people, what is E naught RED? SRP. SRP is given to me. SRP of this electrode is given to me. I think there is electricity cut. I'll have to turn some lights off for some time. I believe it's okay. All right. So basically what I'm trying to say, E naught value is given to me as 0.34 minus 0.0591 divided by N value. N value is how much? 2. And log of QC. What is QC? QC is 10 raised power 19. 10 raised power 19. Now it's a matter of calculation. 0.34 minus 0.0591 divided by 2 log of m raised power n, which is n log m. So 19 comes to the front, log 10 is 1. Solve this and get the answer in volt. That's it. Did you understand this particular question, guys? Did you understand the question? Again, one good question. This is amazing question, I must say. Amazing question, I must say. Yes? Tell me once in the chat if this is clear. Everyone, people. It's a great question. It was in today's mock test. Is that? Now, I believe you would be able to solve this sort of a question if it comes again. Okay, moving on. Tell me the answer of this one. What do you think? Which of the following does not act as a buffer? My dear students, how do you get the acidic buffer? Whenever you have a weak acid and you have got the salt of same weak acid with a strong base. For example, you take CH3COH. It's a weak acid. Take the salt of same weak acid with some strong base. For example, NaOH. That salt would be CH3COONA. This mixture I'll be calling as acidic buffer. Right? Perfect. So which of the following does not make the buffer? So for the buffer, the acid should be weak. But here, the acid is strong. Right? So this is not going to make it's not going to form the buffer. Am I clear? Am I clear, people? Everyone in the chats. This sort of a question is frequently asked again. Okay? This sort of a question, I believe you would have solved this sort of a question many a times, but it's asked. So that's why I came up with this question as well. The molar solubility of AlOH whole thrice in 0.2 molar NaOH. ASP for AlOH whole thrice is given. So first of all, AlOH whole thrice. Tell me, how will it undergo dissociation? It undergoes dissociation as Al tri positive aqueous plus 3 times OH negative aqueous. Right? Let its solubility is S. So this would be S, this would be 3 times S. Correct? Now you are introducing this AlOH whole thrice in what? In NaOH. Let's say this is your NaOH. How NaOH undergoes dissociation? Na positive plus OH negative. Na positive plus OH negative. Right? So technically you are introducing AlOH whole thrice in a solution containing NaOH. What is the concentration of NaOH? Concentration of NaOH was 0.2 molar. In the beginning, this would be 0, this would be 0. Now it's a strong electrolyte, completely ionized, so this would be 0. 1 gives 1, 0.2 gives 0.2. 1 gives 1, 0.2 gives 0.02. I mean 0.2. So I would say you have introduced AlOH whole thrice in a solution of NaOH. Do you see any common ion in between them? Yes, I can see OH negative, OH negative. What is the concentration of OH negative generated from here? 3s. Concentration of OH negative generated from here, 0.2. So total OH negative concentration, it will be 0.2 plus 3s. So you can use the common ion effect and you can neglect S, and instead of that, you can just write 0.2. Right? Now, my dear students, write the expression of KSP. Write the expression of KSP for AlOH whole thrice. The expression is pretty much simple. It is going to be concentration of Al tri positive raised by stoichiometric coefficient, concentration of OH negative raised by stoichiometric coefficient. So I would say KSP value is 2.4 into 10 raised by minus 24. Al tri positive concentration is nothing but S. OH negative concentration is 0.2 raised by 3. Perfect. This can be written as 24 into 10 raised by minus 23. Right? 2.4 I wrote as 24. 24 into 10 raised by minus 23. This can be S. This was 2 into 10 raised by minus 1. It will be 2 into 10 raised by minus 1 ka cube. 2 to 4 to 8 into 10 raised by minus 3. So this is 8.1. This 8.3. So S is equal to 3 into 10 raised by minus 20 moles per liter. This is the final answer of the question. Right? I believe this particular question is clear to everyone. If I'm clear to everyone, let me know once in the chats quickly. If I'm clear to everyone, let me know quickly in the chats, people. Let me know quickly in the chats. Yeah? All right. All right. Look at this particular question, guys. Look at this particular question. I am pretty much sure you will be in a position to solve this one. I am pretty much sure. Yes? What do you think about this particular question? What do you think about this particular question? Everyone. If you look at the question carefully, guys, in hydrogen-like sample, electron makes a transition from fifth excited state. Fifth excited state means N is equal to 6 to second excited state. So electron is making a transition from fifth excited state to second excited state. Second means N is equal to 3. Higher energy state I represent with N2, lower energy state I represent with N1. Correct? Now, if I ask you how many total spectral lines would be observed, I would say total spectral lines formula is nothing but N2 minus N1 multiplied by N2 minus N1 plus 1 divided by 2. So tell me, N2 minus N1, 6 minus 3 is 3. 6 minus 3 is 3, 3 plus 1 is 4 divided by 2. So 12 divided by 2 is nothing but 6. So total spectral lines observed are 6. Total spectral lines observed are 6. Let's again check the calculation. Electron makes a transition from fifth excited state. So N is equal to 6 to second excited state. N is equal to 3. 6 to 3. So 6 minus 3 is 3. 6 minus 3 is 3. 3 plus 1 is 4 divided by 2. So 4, 3, 12. 12 by 2 is 6. So total spectral lines observed are 6. Right? My dear students, if total of spectral lines observed are 6, if I ask you, how many spectral lines will fall into Balmer series? How many spectral lines will fall into Balmer series? That's going to be, the formula is N2 minus ground state of Balmer. N2 minus ground state of Balmer. What is N2? N2 is higher energy state, that is 6. Minus ground state of Balmer, Lyman-Balmer, that's 2. The value comes out to be 4. Right? So 4 spectral lines will be there in Balmer. Similarly, how many spectral lines will be there in Paschen? That will be N2 minus ground state of Paschen. So what is N2? N2 value is 6 minus Lyman-Balmer Paschen. 6 minus 3 is 3. Right? So I can say number of lines which will fall into Paschen series, that will be 3. If I'm clear to everyone, let me know once in the chats quickly. This sort of a question again can be asked in your examination. So be careful with all of this. Be careful with all of this. Tell me, what do you think is the answer of this particular question? Tell me, guys, what is the answer of this particular question? Quickly in the chats. Tell me, what is the answer of this particular question? Quickly in the chats. For an electron, n is equal to 3, and only one radial node, the orbital angular momentum will be. What do you think about this particular question? I'm asking you. People, the question is pretty much simple, but a good one. So n value is equal to 3, right? There is one radial node. How do you calculate the radial nodes? Radial node is also called a spherical node. That's equal to n minus L minus 1, right? And this value is equal to 1 because there is only one radial node. Now n value is already 3. So 3 minus L minus 1 is equal to 1. 3 minus 1 is 2. So 2 minus L is equal to 1, which means that L is equal to 1. L is equal to 1. Azimuthal quantum number is equal to 1. If azimuthal quantum number is equal to 1, that means it's a p subshell which we are talking about, right? N value is 3. N value is 3. L value is 1. What do we have to calculate? Orbital angular momentum. Do you remember the formula to calculate orbital angular momentum? You should know. Under root of L into L plus 1 multiplied by h upon 2 pi. L value is how much? 1. So 1 plus 1 is 2. 2 into 1 is 2. So it's the root of 2 multiplied by h upon 2 pi, which can be written as h upon under root of 2 multiplied by pi. This is the final answer. Do you see any option like that? I can see root of 2 h upon 2 pi, root of 2 h upon 2 pi. This is option number 3, which will be the correct answer of this particular question. Am I clear with this? Once in the chats, quick. Am I clear with this, people? Yes. Again, you should be in a position to solve this question. Now. Few more questions are left and we are done with the session. Few more questions are left and we are done with the session. Tell me the answer of this question. During the disproportionation of iodine, iodine is I2. Iodine is I2. During its disproportionation to iodide and iodate. To iodide and iodate. During the disproportion of iodine to iodide and iodate in alkaline medium, all right? The ratio of iodate and iodine ions will, the ratio of iodate and iodide ions will be. So technically, they're asking us to balance the reaction. Technically, they're asking me to balance the reaction. Let me give you a simple shortcut. Just reverse the reaction. If I reverse the reaction, it's I negative plus IO3 negative gives what? Gives I2. Oxidation state of iodine here is -1. Here the oxidation state of iodine is +5. Here it will be 0. -1 to 0. What is the change in oxidation state? 1. So therefore its n factor is 1. +5 to 0. What is the change in oxidation state? 5. So its n factor is 5. Just crisscross. This 5, make the coefficient here. This 1, make the coefficient here. What do you have to calculate? I have to calculate the ratio of iodate to iodine. Iodate to iodide. Iodate to iodide. Iodate is 1, iodide is 5. 1:5 is the answer. Right? 1:5 is the answer. The ratio of iodate to that of iodide. Right? So 1:5 is the answer. Done? Done, people? I believe I'm clear with this. Okay. One question which I believe all of you can easily solve. Tell me its answer in the chats because there is no calculation needed here. And you love these questions, I know that already. Quickly. Everyone, my dear students. The question says incorrect order of acidic strength. This is the incorrect order of acidic strength. Why? These are the hydrides of group 16. When you talk about hydrides, when you go down the group, size increases, bond dissociation energy decreases, due to which hydrogen will leave as H positive here quickly. You can say something like that, right? So this one should be maximum acidic. But they have given the order in the reverse manner. Down the group, in case of hydrides of group 16, acidic strength increases, right? So it's done. Now, if it is done, tell me Match the following. Match the following. Boron, thallium, gallium, aluminium, indium. Right? You are going to match it with the ionization energy. This is the ionization energy order. This is the ionization energy of group 13. Remember this. It can be directly asked as a question as well. It can be directly asked as a question as well. Ionization energy order in group 13. Chlorine, fluorine, bromine, iodine. This is the order of electron affinity. This is the order of electron affinity. It can be individually asked. Right? It can be individually asked. Chlorine, bromine, iodine. This is the order of electronegativity. This is the order of electronegativity. Boron, gallium, aluminium, indium, thallium. Right? This is the order of your atomic radius. All these four are, they can be individually asked as well. This is the order of atomic radius. This is the order of electronegativity. This is the order of electron affinity. This is the order of ionization energy. Now you can match the following and you can get the answer. These are technically 4 questions. Anything can be asked from this. Okay, so it's option number 2 that matches with everything. Okay, tell me the answer of this one. What do you think? Which set does not show correct matching? Which set does not show correct matching? Chromium, PD5, 4s1. Element belongs to 6th group. Does chromium belong to 6th group? Is it right? How do you get the group number in case of D block elements? N-1d electrons plus ns electrons. 5 plus 1, 6. Yes, it belongs to 6th group. It's right. This one is right. Fe di positive. Iron configuration is 3d6, 4s2. Take 2 electrons out. Fe di positive concentration is 3d6. So this is correct also. Cadmium tri positive. 3s2, 3p6. It belongs to 18th group. Is it a noble gas? No. So this is my correct answer. This is my correct answer. Done and dusted. One more question here. Which order is correct? Which order is correct? Solubility, melting point, acidic character, covalent character. Which is correct? I don't want to look at all the options. I just want to look at one option. If you look at option number D, this is the actual correct order of covalent character. Correct order of covalent character. Here it's Al tri positive. Here it's Mg di positive. Al tri positive. More the charge on cation, more the polarizing power of cation, more the covalent character. So this one will definitely have more covalent character. So it's option D. That's the right one. Okay. All right. Match the following, match the following, match the following. This is something which I believe you can do on your own. Right? Tell me quickly. This is something which you can do on your own, right? Hydrogen bonding, resonance. Resonance will be in O3. Hydrogen bonding will be there in HF, right? This is something which pretty much simple. I'm not going to show this. Moving on to this question. Match the following. Match the following. SF4. 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 What is the hybrid addition? 4 sigma bonds, 1 lone pair. 4 plus 1 is 5. sp3d. sp3d. IF5. IF5. 5 sigma bonds, 1 lone pair. 5 plus 1, 6. sp3d2. Or d2sp3 you can say. sp3d2. NH4 positive. sp3. Right? NO2 positive. 2 sigma bonds, 0 lone pair. So sp. Done? Right? Look here. Well, I should not say D2sp3 for this. It just came out of my mouth. It is sp3d2 only. I have 5. Right? Because 5 sigma bonds, 1 lone pair. 5 plus 1 is 6. 6 means sp3d2. Okay. Look at this one. CO. How many electrons are there in CO? Carbon has got 6. Oxygen has got 8. So it's a 14 electron species. NO. 7 plus 8. 7 plus 8. 15 electron species. O2 negative. 8 2s are 16, 1, 17 electron species. O2, 18 electron species. You know the thing? 14 electron species will have bond order of 3, right? 15 electron species will have 2.5, right? 16 electron species will have 2. 17 electron species will have 1.5, right? 18 electron species will have 1. But 1 is, sorry, this is O2. It's not a 16 electron species. My bad. It's 16 electron species. And you know 16 electron species got the bond order of 2. So this you are going to match with this. This is one more question, and easy question as well. Okay, one more. Incorrect option as per MOT, molecular orbital theory. Incorrect option as per molecular orbital theory. Be2 is not a stable molecule. Is it incorrect? Be2. Be2 is not a stable molecule. Which of the following is incorrect? Which of the following is incorrect? Incorrect. This is correct. It is not a stable molecule. This cannot be my answer. He2 is not stable molecule. Correct. He positive is expected to exist. Yes, correct. Bond strength of N2 is maximum among all homonuclear diametric molecules. Yes. Why? Because N2, bond order 3, more the bond order, more the bond strength. This is correct. Order of molecular orbital energy is in F2. Is this correct? Is this correct order? This is incorrect order, guys. Incorrect option is the last one. F2 is 18 electron species. It is not going to follow this order, right? Of filling the electrons. Absolutely. It's option 4. That's going to be the answer of the question. All right, tell me the answer of this question. Which is not correct? Well, I can directly see this option. This is not correct. HF is more volatile than HCl. Is that right? In HF, there is hydrogen bonding. Because of hydrogen bonding, it will be less volatile. Because of intermolecular hydrogen bonding, it will be less volatile. Here they have mentioned more volatile. So this is incorrect. Rest all the options will be correct only. Orthonitrophenol can be separated from meta and para using steam volatile property. Yes, that's correct. Similarly, HF has zigzag structure. Yes, correct. That is HF solid basically. Ethylene glycol is less viscous than glycerol. This is correct. So only incorrect option is this option number C. Okay. Well, these are 4 options. That means 4 different questions. 4 different questions. Have an eye on this as well. Okay, 2 more questions and we are done. 2 more questions and we are done. The compound that does not produce N2 gas by thermal decomposition. Remember, it's a memory-based question. It will be option A only. NH2, NH4 twice SO4. It does not give N2 gas. It does not give N2 gas upon decomposition. Rest all give N2 gas. This, when it undergoes decomposition, it gives N2 gas. This one undergoes decomposition, gives N2 gas. This one undergoes decomposition, gives N2 gas. Right? So this one is the only one that does not give N2 gas upon thermal decomposition. Remember it, it's again a memory-based question. Chlorine water on standing loses its color and forms what? Chlorine water on standing loses its color and forms what? It forms HCl and HOCl. HCl and HOCl. HCl and HOCl. That's option number D. That's the correct answer of the question. Perfect. My dear students, I hope whatever questions I came up with today, you loved all of them. I'm pretty much sure because all the questions were super amazing. Not the ordinary questions, I must say. Right? If you are thinking the same, yes, the questions were not very ordinary, right? Do let me know in the comment section of this particular video as well, so that I'll come up with similar sort of questions in the tomorrow session as well. Tomorrow there is one amazing session, guys, right? Top 100, complete chemistry revision in 100 MCQs. You're going to love that session. So that session starts at 9 p.m. All right, be there. And the PDF of this session I'll be sharing on my Telegram as well as on my WhatsApp channel. If Telegram is not working for you, then join my WhatsApp channel. The link of my WhatsApp channel I have shared on my Telegram channel. If you open the Telegram, right, open my channel, you'll find a link. Click on that link, you'll get added to WhatsApp group. Okay, do that quickly. Chalo guys, I'll be waiting for your comments. I would want to know in the comment section whether you like this session or not, whether you find the questions amazing or not. I would want to know that in the comment section of this particular video. Till then, you take care.